Hello everyone, here we discuss the topic of inorganic chemistry. That is our lesson number 9, elements of group 13, 14, 15, which is basically from inorganic chemistry. This is our lecture number 9. Now see the objectives of lesson. So which topics we covered? Now see here the reactivity towards air, order of acidic nature of oxides of group 15 elements, reactivity towards acids, alkalis and the halogens of group 15 elements, and the allotropic nature of phosphorus is the last point. Allotropic nature of phosphorus is the last point of the lecture number 9. So now first of all we discuss the reactivity towards air, order of acidic nature of oxides of group 15 elements. Now see here, first of all we look the chemical properties of group 15 elements. In that first of all we look the reactivity towards air of group 15 elements. First of all, reaction with air, reaction with oxygen. See, there are mainly two types of oxides are formed here, trioxides and pentoxides. So first of all we look the general reaction of trioxide. 4E plus 3O2, it gives twice E2O3, that is trioxide. So example we can take here, आपण example घेऊ शकतो. P4 plus 3O2, it gives twice P2O3 or P4O3, that is called as phosphorus trioxide. After pentoxide, so there are 4E. Element means there is a any element from the 15 group, phosphorus, then nitrogen, so we can take any kind of element, plus 5O2, it gives twice E2O5 or E4O10. We can take the example. So when the E4 reacts with, means 4 moles of element reacts with the 5O2 or reacts with the air, 5 moles of air, we get the pentoxides. For example, we can take here phosphorus. When the P4 reacts with 5O2, we get the phosphorus pentoxide or P4O10. Okay. Now next point, the trioxides of nitrogen and phosphorus are purely acidic. बघा जे ट्रायऑक्साइड्स असतात नायट्रोजन आणि फॉस्फरसचे ते प्युअरली ॲसिडिक असतात. बिकॉज आफ्टर दॅट वी लुक द आपण त्यांच्या ॲसिडिक नेचर किंवा बेसिक नेचर बघणार आहोत ऑक्साइड्सचे. सो फर्स्ट ऑफ ऑल वी लुक सम इम्पॉर्टंट पॉईंट्स हियर. द ट्रायऑक्साइड्स ऑफ नायट्रोजन अँड फॉस्फरस आर प्युअरली ॲसिडिक. दॅट ऑफ आर्सेनिक अँड अँटीमनी आर ॲम्फोडरिक. तर आर्सेनिक आणि अँटीमनीचे ॲम्फोडरिक इन नेचर असतात. And bismuth is a predominantly basic in nature, and bismuth, the trioxide of bismuth is basic in nature. So this is very important point. जे काही ट्रायऑक्साइड्स असतील नायट्रोजन आणि फॉस्फरसचे ते ॲसिडिक नेचर दाखवतील, and the trioxides of arsenic and antimony shows the amphibolic nature and bismuth shows the basic nature. And note that the higher oxidation state molecules are more acidic than lower oxidation state. म्हणजे pentoxides जे काही आहेत they show the more acidity than the lower oxidation state than the trioxides. See the order of acidic nature. Here N2O5 is more acidic than P2O5, then AS4O6, that is AS2O3 trioxide also, SbO3 antimony trioxide, bismuth trioxide. Now see both first are acidic in nature. Already we looked the note in the previous point, that is higher oxidation state oxides are more acidic in nature. So these are the more acidic. These are the trioxides, that is arsenic trioxide and antimony trioxides are the amphibolic in nature, and the bismuth trioxides is the basic in nature. Predominantly we look in the last point. So all pentoxides are acidic in nature. So this is important point. Note that except the bismuth, other elements form the pentoxide and which are represented by M4 means E4O10. Reaction with water we look now. See the trioxides dissolve in water and giving us acids means at the suffix आपण सफिक्सला एंडिंगला OUS acids असं लिहितो and in the pentoxides dissolves in water then the suffix with IC that is ic acids at the end IC लिहितो. Now we look the example. See here P2O5 twice mole of phosphorus pentoxide react with 6 moles of water, we get the H3PO4 4 moles of phosphoric acid. See here आपण इथे सफिक्स काय लावला IC लावला आहे. Okay, so pentoxide when dissolves in water we get the what phosphoric acid. आपल्याला काय मिळाला phosphoric acid मिळाला. See here and now trioxides when dissolved in water, phosphorus trioxide when dissolved in water we get the phosphorus acid. So here suffix with OUS. So this is the important point, note it. खूप महत्वाचं आहे. Pentoxide when dissolved in water they give the phosphoric acid means IC suffix with the ic acids, and when the trioxides dissolve in water they give the us acid that is OUS suffix with OUS. So here we take the example, so remember it. Now see here reaction with halogens. Generally when group 15 elements react with halogens they form trihalides and pentahalides, two types of halides. So first of all we look at trihalides. इथे आपण जनरल रिॲक्शन बघू पहिले. 4 element when reacts with 6 moles of X2 we get the 4 moles of EX3. आपण suppose इथे example घेऊ. Element means we take here phosphorus. So element we can take any element of group 15 elements. आपण इथे कोणताही element घेऊ शकतो group 15 मधला. So here we take phosphorus and in case of X we take the chlorine. So आपण X च्या ऐवजी आपण chlorine घेऊ. So now see the example. When 4 moles of phosphorus react with 6 moles of Cl2 we get the 4 mole of PCl3. So in this way we get the phosphorus trichloride. हे आपण example घेतलाय. Now in case of pentahalides, see when 4 moles of element reacts with 10 moles of X2 we get the 4 moles of EX5. So in this way we get the pentahalides. So here also we can take the example of phosphorus and chlorine. म्हणजे आपण इथे एलिमेंट्सच्या ऐवजी phosphorus घेऊ आणि X च्या ऐवजी chlorine घेऊ. So when 4 moles of phosphorus or P4 when reacts with 10 Cl2 we get the 4 moles of PCl5. आपल्याला 4 moles PCl5 मिळतील हे लक्षात ठेवा. So in this way we get the phosphorus pentachloride. And now here we look at some important points of trihalides and pentahalides. बघा all the trihalides of these elements except the nitrogen all are stable. म्हणजे नायट्रोजनचे जे काही ट्रायहलाइड्स नायट्रोजन फॅमिलीचे जे काही ट्रायहलाइड्स आहेत ते सर्व स्टेबल आहेत नायट्रोजन सोडून. इन केस ऑफ नायट्रोजन ट्रायहलाइड्स फक्त नायट्रोजन ट्रायहलाइड्सचं आपण जर बघितलं तर NF3 इज स्टेबल मीन्स नायट्रोजन ट्रायफ्लोराईड हा स्टेबल आहे. फॉर एक्झाम्पल जर NCl3 घेतलं नायट्रोजन ट्रायक्लोराईड इज अनस्टेबल बट NF3 इज स्टेबल बाय म्हणजे जे जेवढे ट्रायहलाइड्स आहेत त्यांच्यापैकी फक्त NF3 हा स्टेबल आहे. नाउ नेक्स्ट इम्पॉर्टंट पॉईंट दॅट इज ट्रायहलाइड्स एक्सेप्ट द BIF3 ऑल आर प्रिडॉमिनंटली कोव्हॅलंट इन नेचर. BIF3 सोडून बाकी सगळे कोव्हॅलंट इन नेचर आहे. नाउ वी लुक द सम इम्पॉर्टंट स्ट्रक्चर. आपण इथे स्ट्रक्चर बघणार आहोत PCl3 आणि PCl5चं. आपण आत्ताच बघितलं होतं एक्झाम्पलमध्ये PCl3 दॅट इज फॉस्फरस ट्रायक्लोराईडचं आपण एक्झाम्पल घेतलं होतं आणि फॉस्फरस पेंटाक्लोराईडचं एक्झाम्पल घेतलं. नाव हिअर वी लुक फर्स्ट PCl3 मॉलिक्यूल. बघा सो हिअर देर इज अ वन लोन पेअर. इथे एक लोन पेअर आहे. ओके इन PCl3 देर इज अ वन लोन पेअर. फर्स्ट ऑफ ऑल वी लुक द हायब्रिडायझेशन. फॉर द हायब्रिडायझेशन लोन पेअर ऑल्सो कन्सिडर. So there are 4 sides. जर आपण काउंट केलं this is one side, second side, third side and 4 sides. 4 sides are there. So all 4 sides are count and that's why the hybridization is here. Phosphorus shows sp3 hybridization. So sp3 means what? p3 and 1s, so there are total 4, so 4 sites are there, so that's why it shows the sp3 hybridization. This is the very simple technique to identify the hybridization. आपण hybridization identify करायला ही सोपी टेक्निक यूज करू शकतो. So because of sp3 hybridization, this PCl3 shows tetrahedral geometry. So this shows the distorted tetrahedral geometry. Here PCl3 shows the distorted tetrahedral geometry, and it shows the trigonal pyramidal shape. PCl3 हा trigonal pyramidal shape दाखवतो, so keep it in your mind. And next one, we look the PCl5. See here, there are 5 PCl bonds, means 1 2 3 4 5. Out of 5 PCl bonds, 3 PCl bonds are lie in one plane. हे एकाच प्लेनमध्ये आहे, हे बघा, आणि हे दोन त्या एका प्लेनमध्ये नाही आहेत. ओके, एक अबव द प्लेन आणि एक बिलो द प्लेन आहे. सो in PCl5, so there are phosphorus, so there are total 5 bonds are involved. So very easy method to identify the hybridization. आपण इथे simply hybridization identify करू शकतो बघा. So it shows 5 bonds, so that's why it shows the sp3d hybridization. हा sp3d hybridization show करतो. So sp3 means 4, p3 and 1s and 1d, so sp3 4 and this 1d, so there are total 5 bonds are involved there. So that's why it shows the sp3d hybridization, and that's why it shows the trigonal bipyramidal geometry here. हा trigonal bipyramidal geometry show करतो. So this is the very important information about the structures. Anomalous behavior of nitrogen. Common reasons already मी तुम्हाला सांगितलं आहे. The first member of family, the first member of every group shows the anomalous behavior. Nitrogen also shows the anomalous behavior. The common reasons: absence of d orbitals, it is small in size. Okay, this atomic size एकदम small असते. Very high electronegativity, that is 3.0. Very high ionization enthalpy, that is 1402 kilojoule per mole. This is the first ionization enthalpy. Next one, nitrogen has the unique ability to form the pi multiple bonds with itself. आणि ह्या तो स्वतः दाखवतो. हे स्वतःचे त्याचे properties आहेत. Other group members not show the properties like this, so it is different than other members, so that's why it shows the anomalous behavior. Next one, allotropic nature of phosphorus. In our syllabus it is concluded. See, the white phosphorus, it is also called as yellow phosphorus. It is a translucent and waxy solid. Common variety आहे या phosphorusची. P atoms are lie at the corner and regular tetrahedron. आपण आता स्ट्रक्चर बघणारच आहोत त्याचं. Each phosphorus is bonded with 3 other phosphorus by covalent bonds, and it is poisonous. See the structure. The bond angle is 60 degree, and this is the tetrahedron structure of P4. Okay, so each phosphorus is attached to another 3 p atom by the covalent bonds. हे लक्षात ठेवा. Okay, each phosphorus is attached by another 3 phosphorus. बघा, हा phosphorus जर आपण बघितला, याला अटॅच आहे, याला अटॅच आहे आणि याला अटॅच आहे. ओके, हा phosphorus जर बघितला, this phosphorus is attached to this phosphorus and this phosphorus. So this is the tetrahedron structure of white and yellow phosphorus. After red phosphorus, it is polymeric. Baga, this is the structure of red phosphorus. Here each phosphorus atom is attached to another 2 phosphorus atoms. It is non-poisonous, it is odorless. It is obtained by when white phosphorus heated at 573 Kelvin in inner atmosphere for several days. म्हणजे white phosphorus पासून तो आपल्याला मिळतो. It is non-poisonous as and insoluble in water as well as carbon disulfide. CS2 मध्ये तो insoluble आहे, water मध्ये सुद्धा chemically red phosphorus is much reactive than the white phosphorus. White phosphorus पेक्षा खूप reactive असतो. It is polymeric and it consists the P4 tetrahedral link together, म्हणजे तो P4 tetrahedral link दुसऱ्या P4 ला कोव्हॅलेंटली जॉईन करतो. बघा ही P4 एक लिंक आहे. P4 एक tetrahedral structure. It is linked with another P4 tetrahedral structure, and this tetrahedral structure is also linked with another tetrahedral structure. So this is the important part. This is the red phosphorus. And the last phosphorus, that is black phosphorus, which is thermodynamically more stable. हा सर्वात जास्त स्टेबल फॉस्फरस आहे, हे लक्षात ठेवा. It is mainly formed by अल्फा ब्लॅक अँड बीटा ब्लॅक. हा याचे दोन फॉर्म्स आहेत, एक अल्फा ब्लॅक आहे आणि एक बीटा ब्लॅक आहे. रेड फॉस्फरस गिव्स अल्फा ब्लॅक फॉस्फरस अँड व्हाईट फॉस्फरस गिव्स बीटा ब्लॅक फॉस्फरस, हे लक्षात ठेवा. सो ब्लॅक फॉस्फरस हा रेड आणि व्हाईट फॉस्फरसपासून आपल्याला मिळतो. रेड फॉस्फरस गिव्स अल्फा ब्लॅक फॉस्फरस अँड व्हाईट फॉस्फरस गिव्स बीटा ब्लॅक फॉस्फरस. Note that it does not get oxidized easily with air. It can be sublime in air and opaque, monoclinic or rhomhedral crystal. Okay. Multiple choice question. Phosphorus exists in white, digest and black forms. Blue, red, gray. None of this already we know. The red phosphorus is also there. White, red and black. These three forms. Digest does not show allotropic. फक्त bismuth does not show the allotropic. Other members of the group show the allotropic forms. Thank you.